So, last class we are done with module 5. So, there we discussed about the signals, okay, different types of the signals generated by the process, how it can handle the signals, okay. So, coming to the fourth module, so in the fourth module, we are going to study 3 chapters, okay. So, first chapter is about the continuation about the process, okay. So, different functions we are going to study in first chapter. Second chapter is about all about inter-process communication, how the communication can happen between processes. Okay. And the last one is about shared memory and client server properties. Okay. First point, you're going to study about changing user IDs and group IDs. Okay. So we already studied in our first module how to change the user IDs and group ID. Okay, chmod command. Okay, and similarly one more chgroup command to change the group ID. So we can set the real user ID and effective user ID with the set UID command. Okay, so this is a function set UID. Okay, so if you see come across a process, okay, the process will be having different types of IDs. Okay, just to show you, so it will be having real user ID, effective user ID, saved set user IDs. Okay, there are different types of IDs, okay, available for a process. Now this first function set UID we can be used to set the real user ID and effective user ID. Okay, so these function, the first function, and similarly we have one more set GID. So set GID, the difference is here it is for user, this is for group. Okay, very simple to remember. So this is used to set the real group ID and effective group ID. The first one is to set real user ID and effective user ID. Second one is to set real group ID and effective group ID. Okay. So here, if everything is fine, then it will return 0. If there is any problem, then error, it will return -1. So there are few rules. Okay. These are the rules for who can change the IDs. Okay. So, like when we say the person can change the user ID like real or group IDs, so here the first question comes: who can change the ID? Whether all the user are have the permission to change the ID, or only the super user permission, or the root user can only change the ID. So these things you need to know. So let's consider that only the user ID for now. Okay, we'll be considering only user ID. First thing is, if the process has super user privilege, okay, this is very important. Only the user with the root permission, okay, if the person is having root permission, then set UID function can be used to set the real user ID, effective user ID, and saved set UID, user ID. Okay, so we need a super user privilege. The second one is if the process does not have super user privilege, okay, the process does not have this permission, then SUID sets only, okay, this first function can be used to set only the effective user ID, okay. The real user ID and the saved set user ID are not changed. If he is not having any super user privilege, then only he can change the effective user ID. Other two, it is not possible to change. If neither of the two condition is true, okay, if neither of the two condition is true, then error number is set to 2. So what is error number? It is set to this is the constant value it will throw, and 1 will be returned. The integer 1 value will be 1 will be returned. So here you can see, so these are the 3 types of ID: real, effective, and saved set user IDs. And here you can see there are two types of uh, there, there are two different ways you can change the three user IDs. Okay. Here one is this exe. Okay. Another one is this set UID. So you can see here what and all you can change and what you are not able to change. Okay. So here in exe, if this bit, okay, exe function is having a particular bit which we call it as set user ID bit. If this is off, okay, you can also make it on. So there are two possibilities, on and off. So if it is off, then you are not able to change the real effective IDs. Okay. Then this you can change, that is copied from the effective user ID. Okay. If this particular bit is on, then you cannot change the real user ID, but you can change the effective user ID, but that ID will be set from user ID of the program file. Okay. So similarly, you can see what happens in the case of set UID. If you are having super user permission and if you are not having super user permission. If you are having super user permission, you can change all the three IDs. Okay. If you are not having super user permission, you can change only the effective user ID. The other two you cannot change. So this Tableau diagram shows different ways to change the three user IDs. Okay. The next function is so here set REUID and set REGID function. Okay. So in certain Unix operating system, okay, it supports swapping of real user ID and effective user ID using this function. Why this function is used? For swapping the real user ID and effective user ID using this function. Okay. So here, so this is for the user and this is for swapping group IDs. Okay. So here, if everything is okay, it returns 0 or it returns -1 on error condition. Next, one more function is set EUID and set EGID function. So remember all these functions. The possibility that you will get confused if even a single character, if you miss, then the function name itself will be wrong. Okay. So here, set EUID and set EGID functions. These two functions can change only the effective user ID and effective group IDs. Okay, there are three types of IDs, correct? Effective, real, and one more is your saved set user ID. So among these three, these two functions can be used to change only the effective. This E stands for effective, effective user ID and effective group ID. Okay. An unprivileged user can set its user ID, that is effective user ID, to either its real user ID or it's saved as set user IDs. Okay. So this diagram summarizes all the three functions, all the functions we have studied so far. Okay. So all the functions that can set the different user IDs. You can just go through this. Okay. There are three types of IDs. Okay. And you can see this is for swapping, this is for setting, and this is for setting effective user IDs. So if you are a super user, okay, if you are having super user permission, what and all you can change using this functions. So if this is a function using super user, you can change real as well as effective user ID. Then using this function, you can change all the 3 IDs. And using this, if you are having super user permission, you can change only the effective user IDs. Okay. And this is for swapping. Okay. So how the swapping occurs? Okay, you can also use unprivileged user also can perform the swap. So you can see here, if you are a unprivileged, if you are not a root user, unprivileged user, you can change from, okay, you can set, okay, effective user ID as well as the real and this one effective user ID is using this function. If you know the real user ID, okay. If you know the real ID, you can change it to effective user ID or from this vice versa. Okay. And also it shows about exe function. The exe function can also be used for setting effective user ID as well as saved set user IDs. So this one particular diagram shows in detail what and all you can change. So the next topic is interpreter files. Okay. So here, so this interpreter files are similar to the text files. Okay. So when you look into this file, interpreter file, it looks similar to the text file, but only difference is that begins with the line of the form like this. Okay. So it will begin with the line hash exclamatory and something you will be having that is optional. First thing is a path name, followed by you will be having an optional argument. Okay, so this square bracket indicates it is a optional argument. Okay, so the space between the exclamatory and the path name, the space you can see, it is optional. Okay. So the most common type of interpreter file is this. So when we have written, when we started studying about the Unix programming, okay, the first line what we have written is this hash exclamatory slash bin slash hash. Okay, if at all if you want to execute any shell program, okay, for executing the shell program, it will be using a file which is there in this particular path name. So here, this is a format. Okay, format is the first line. Okay, the first 2 characters should be hash exclamatory. Okay, and after that there should be a path name. So here the path name is slash bin slash hash. Here the path name, okay, it is normally an absolute path name. Okay. So here the thing is, what should be the length of the path? Okay. So in some Unix operating system, there will be length of 32 characters. Okay. So maximum how many characters you can have? You can have 32 characters for the first line of the interpreter file. So here we have a program. Okay. So you can go through this program. Okay. So here in this program, okay, you have exe function. You can see here, this is exe function. If you remember, in our third module, we discussed about exe function. So this is your third module. We discussed about exe function. So what is the exe function? So exe function, okay, when a process calls one of the exe function, there are how many exe function? 6 exe function. Okay. So one of the exe function, then the process is completely replaced with the new program. So here, okay, so here the path name of the new program will be specified. Okay, your entire execution of the particular program will be stopped and it will start executing the new program which is there in this path name. Okay. Then the new program starts executing at its main function. So your current program execution, assume that we have a lengthy program. Okay. So when you encounter this exe, any of the 6 exe, okay, it will stop the execution of the current program and it will start the execution of the program which is there in the particular path name. Okay. Sometimes it can also be a file name. Process ID does not change across exe. Okay, so process ID, it is not this other process that is running this program which is there in the particular path. It's the same process running the program which is there in the particular path. Okay. Because the new process is not created, it is just replacing the current process. Okay. So this is the exe functions which we have studied in third module. If you see here, here we are having the exe function. This is our exe function. This is our path name, and these are all arguments. So that is the format. Okay. First is path name, comma, rest all are the arguments. Okay. So here, this is a path name, and the remaining, as you can see, the comma, these are all, here they are all arguments. Okay. Now, this is an interpreter file. This is an interpreter file. I just write IF. This is an interpreter file. So you can see here, when you just execute the cat command, if you remember, the cat command is used to see the content of the file. Okay, if you execute this cat command and cat followed by the entire path name followed by the file name of the file, so this is a file name. Okay, it will show you the content of the particular file. So here you can see this is an interpreter file. You can see hash exclamatory symbol followed by that this is the path name and this is our optional argument. Okay. So here exe function it is having, okay, when it is executed it will be redirected to an interpreter file and there is an optional argument on the first line of the interpreter file. Okay. So when we execute this program, okay, so here you are creating, okay, so this is our parent process and parent process when you execute fork system call, so it will create a, so this is your main program and main program is having a process. So this is entire is your main program which is, it is when you are executing a process will be created. Okay. And here when it executes the fork system call, it will create a child process. It will creating a child process. So if it is -1, if it is less than 0, so you can tell there is an error. Okay. And once it is able to successfully create the child process, the child will be returned with the value 0, the parent will be returned with the value greater than 0. Okay. So here, when you encounter that is a PID, so this is a PID, okay, process ID. If the process ID is 0, then we can understand that it is a child process. The child process ID will be 0. Okay. So here the child process, what it does, the child process will execute this exe. Okay. So here you can see here. So when it enters, okay, so the child process starts executing this exe. Okay, in the exe, if we encounter, here we are having the path name home sar/bin slash echo arg. Okay, so this is a program. Okay, so the program name of the program is what? Echo argument. Okay, the program echo argument, that's the interpreter. Okay, just echoes each of its command line arguments. So here we are not showing this program. Actually, in this program, what we are having is we are having the main statement, and inside the main statement, okay. So here we are having a for loop, okay, for displaying all the arguments. Okay, I is equal to 0, I less than argument count, which is given by argument C count. Okay, I plus plus, and inside this for loop we are displaying all the arguments. We will be having a printf statement. Okay, and write complete printf statement to print, okay, argument. Okay, we can write that I value and all, okay, percentage d and all. You have to write, you have to display argument, and followed by that we are displaying the string, okay, on the particular argument. Okay. That is, we're trying to display argument of I colon the string we are trying to display. So this print of statement will be something like this. Argument percentage d colon percentage. So here it is. This is percentage I is, percentage d is for I, and percentage s is nothing but the value that is there in the particular argument. That is argument b of I. Okay. So you are trying to display, okay, argument. Okay, this is just a string argument, number of argument number, and argument value. We are trying to display this. Okay. So that is there in this echo arg, okay, file, and this is the optional parameter. Now, when the program, okay, when it passes to this and to start executing this, okay, when we start executing this echo arg, so this part when you start executing, okay. So first thing is I is equal to 0. That is what ARV of 0. Okay, ARV percentage D is nothing but that is I value. It is of 0 colon percentage S. Percentage S is what? Argument V of I. So that is nothing but argument, the first argument value. What is that first argument value? That is nothing but this. Okay, the path name of the interpreter. So first thing is the path name of the interpreter, that is this one. Okay, and next I will get incremented. I will become ARV of 1. Okay, second one is the optional argument from the interpreter file. What is the optional argument? Next one is 2. Okay, that will be displayed. And what is the remaining arguments? The remaining arguments are the path name, that is our file path name. Okay, so that is this file path name, that is this. This is our argument. Argument 2, that is this path name. So argument of next arguments are the path name. Okay, and the second arguments are the next one will be this. Okay, this will be our next argument. Okay, and the last one will be this. So here you can see how it will display different types of arguments. So this is how this program shows you, okay, how exe function can be used to call and execute an interpreter file. Okay, so this is an interpreter file which will be having this particular code, okay, for displaying all the arguments. So this is the output. Okay. So argument 0 is nothing but this interpreter path name. Second one is an optional argument. Second one, the next argument of 2 is this. Okay, our path name in the exe file, and argument V of 3 is this. Okay, and argument 4 is this next argument. So the next one is system functions. So if they ask you in the exam about interpreter file, you can explain this, okay, and you can give one example with the output. Okay, system function. So it is a convenient way to execute a command string from within a program. Okay. So it is possible to execute any commands within a program. For example, we can execute ls command, echo command, printf command, cat command, or any command you can execute, okay, within a program. So here system is used. So this is a function. System is used to invoke an operating system command from C or C++ program. So this is a function is used for executing any command. Okay. If you remember, I had already shown you this system command. Okay, system function for executing system ls, okay, where it displays all the file name. So this is a prototype. Okay, we need this header file and system, and inside the bracket we'll be writing the name of the command. So here for example, we can put a time and date stamp into a certain file. So I want to display the time. So I can simply write system and inside the bracket I can write the command name. So I would like to display the date in the double quotes, and I want to redirect the output into a certain file. Okay. So whatever the output you get, you just copy it into the name of the file. Just give the name of the file. For example, file 1. So it will execute the date command. So whatever the output, for example, today's date, it will display 17/11/2020, and that output will be sent to this particular file. So when you try to display this file, you will be having the date of the today's date. Okay. So you can see these are few examples. So here, these are all command strings. Whatever you see in the double quote, they are all command string. Okay. So here we have different commands: ls, clear, gcc, execution command, cd. Okay, these are all different commands you can execute using C program or C++ program. So system function, it returns non-zero only if the command processor is available. If it is able to execute this command, it returns non-zero value. So this is an example. So if you see this program, okay, so we have two set of programs. Okay, these are the two set of programs. So first let's discuss, this is the main program. And this is our system function. Okay. So these are two separate sets. Okay. So this is our main program, and this is the definition of the system function. So in the main function, what and all we are having? We are having a status. Okay. And here we are trying to display argument is less than 0. Number of argument is less than 0. So command line arguments are required. Here, okay, we are passing the commands. Okay. So in the command line itself, we are passing the commands. So for example, we are trying to execute the file. Okay. We are trying to execute the file, and there itself we are passing the command. For example, ls command. So here, minimum. Okay, minimum we need two arguments. Okay, one for execution of the file, and another one, at least one command should be passed. Okay. Here status is equal to system of argument of 1. Okay. So here we are trying to execute the command line argument using system. So here the argument 1 is ls, so that is passed. So it will just trying to execute this ls command. So if there is any error, it will display the error message. And here PR exit. Here PR exit. Okay. So this PR exit is a one more function. Okay. This definition is not given here. So this is used to display the status after executing this ls command. Okay. So it will display the status. Here, what is there in the system function definition? So here we are first it is checking whether the command what we are passing it is a ls command. So ls command whether it is null. If it is null, return 1. Okay. Then we are creating a process. Okay. Process ID is less than 0, return an error message. Okay. And if it is child process, okay, we are using execute, okay, exe. So exe, as we saw in the previous one, so exe is similar to the previous program. Okay, here it is having the path name. These are all arguments. Okay. So this is a path name. So it will stop the execution of the program when it encounters this particular line, and it will passes the control to the kernel. Okay, it will passes the kernel to the shell script. So here in the shell script, we are trying to execute the command. So this line will execute the command. So here we are using -c option. So -c option tells to take the next command line argument, that is this. So this is what? This is nothing but your ls. Okay. This is our ls. So this, if you are giving this -c, so it will tell that to take the next command line argument, which is nothing but our ls. Okay. As a command input. Okay. And the shell parses this null terminated C string and breaks it up into separate command line argument for actual command. Okay. So it will start executing this ls command. The shell will start executing this. Okay. So this is one where we pass the command line argument. In the command line argument itself, we are passing the command and we are calling the system function. The next one is, okay, here you can see this is one more way. Here we are having price. We are calling the price. We are calling the system function. Okay, you can see here, here, and here. Price we are calling the system function. So here, the first time we are calling the system function and we are passing the valid date. Okay, it's a command, right? Date is a command. We are passing the valid date. Okay, and then we are trying to. This is a function. Okay, we are not showing the definition of this function. This is for displaying the status. So when we execute these two lines, what it will do is, if everything is okay, it will display date. Okay, probably today's date, okay, 11, no, sorry, November 17, okay, with the system date, time, everything it will display. And this PR status, okay, PR status, what it will do, it will display the status. So it will give normal termination, okay, comma, if everything is okay, it will display the exit status is equal to 0. Okay. So 0 indicates what? Successful execution of the command. Okay. Now come to this next one. Now you are trying to execute a command. So you are trying to give a name of the command, okay, which is a dummy value. Okay, there is no such command with the name, no such command. So just a dummy value you are trying to pass. Okay, now what happens? So in this case, what it will do, it will display the message. Okay, it will display the message not found. Okay, because there is no such command with the name no such command. Okay, it will display not found, and this terminating status, what it will display? It will display the exit status is equal to 1. Okay. The next one is there is one more system function. This system function is taking this as a parameter. So what is this? There are two commands. If you remember, we are combining the commands using semicolon. Okay. So we are passing what? There are two commands. One is who command, another one is the exit command, and we are passing the exit status as 44. Okay. So if you remember this who command is used to tell who are the users who are using the system. Okay. So it will display okay, username, group name, everything. It will display the output. Okay. It will display the username, group name, then date, time, everything it will display. Not just one, okay, multiple lines it will display who and all are using the system. And finally, we are executing the PR exit command. So exit command, we are already passed exit status. What is the status? It is 44. So what it will display? Normal termination, comma, exit status is equal to 44. Okay, so this is a program where it shows okay, the execution of three system functions. Okay. So in the first one, we are passing the valid command, and if everything is okay, it will display the exit status as 0. Second one, we are passing some dummy command name, so it is displaying greater than 0 value, that is 1, it will display, any other value it will display. Okay, here what we are doing is we are executing valid who command, and here you are itself you are telling what is exit status, that is 44. So normal termination exit status is equal to 44. So this is so these are the two examples. Okay. So here what we are doing, we are executing, we are passing okay the command line argument. In the command line argument, we are passing the command okay that will be fetched using argument v of 1, and then what we are doing, we are passing to the system function, their system function, how it will execute the function. Here we are calling, we are giving the path name of the shell program, okay, shell execute the command, okay, and here the -c option tells to take this ls command as a command input for execution. So that command will be taken and it will be executing the command. Okay. So this is how, okay, actually when you are executing the program, okay, simply if you give, instead of this, simply if you give system of ls, okay, it will execute the program and it will give you the output. Okay. Now in the uh, slash bin slash sh, okay, if you open this system, it's actually a function, right? It's a built-in function. Actually, when you open the system function, this is what the code will be there. This is a built-in code actually, okay? You are not writing this code. It is a built-in code. Okay, so that is, these things will be there inside this particular system built-in function. If possible, we could able to see that system. This is all about system function. Next one is process accounting. So we'll see in the next session process accounting. So today's class we studied about changing the user ID and changing the group IDs. What are the different functions available for changing the IDs? Okay. Next we discussed about uh, interpreter file, okay, which starts with hash exclamatory symbol. Okay, such files are called as interpreter files. And the last topic we discussed about system built-in function. for executing the commands, any Unix commands inside C or C++ program.